Good evening, this is Sayadri and I am recording my demo video for mathematics, and the topic that we are going to cover is continuity and differentiability. It is a very interesting one. So let's start. Firstly, we will cover it one by one. So we are going to discuss continuity. So what is this property? This is the property of a function, which does not break down at any point. So a function does not break down at any point said to be continuous. So a continuous function is a function that does not break down at any point. So like if you want to see some examples, fx equal to x, this is that function a straight line, y equal to x. So this function is a continuous function. This is a continuous function because it is not breaking down at any point. You can draw it without lifting your marker. So if a function can be drawn, a graph can be drawn without lifting the marker, this will be called continuous. Let's take another example like fx equal to x square. So it will be somewhat like this. This is also a continuous function. This is also a continuous function. Why? Because this can also be drawn without lifting the marker. In graphical method, we can say without lifting the marker, we can draw this is the continuous function. But let's see another one. Now, for example, a function is fx equal to 1, 2, for x greater than equal to 0 and x greater than equal to 0, x greater than equal to 0 and x less than. For example, this is the type of function. So if you want to draw this, it will be like 1, 2 and greater than equal to 0. So for here x greater than, it will be 1, that one line, and for less than 0 it is 2, so that 2 line. But less than 0, so it will be like for x less than 0 means this side, because this is x-axis when you say. So less than 0, negative side, this value is 2. For positive side, this value is 1. So this is a graph. But when you are drawing this from here to here, you have to lift the marker. Or we can say this function is breaking down at point 0. Right? So if we are lifting this marker by drawing the graph, this will become a discontinuous function, and the point of discontinuity is 0. Okay, so the point at which a function becomes discontinuous, that will be point of discontinuity, like in this case it is 0, x equal to 0. So this is a general introduction of continuity. Okay, these two are continuous functions. This one is discontinuous function with point of discontinuity x equal to 0. Okay. So this is introduction of continuity. Let's go to differentiability. Okay, so now we are going to discuss about differentiability. Okay. So simply we can say a function may be differentiable function or non-differentiable function. Right? So a function can be differentiable, either differentiable or non-differentiable. So how we will identify? Firstly, we can say differentiable function will be function of which at any point slope can be determined. It's very clear. If at any point you can determine the slope, that function will be differentiable function. And for non-differentiable function, if the slope can't be determined at any point, so that will become, if the slope cannot be determined at any point, that will become non-differentiable function. Generally we say, this is a very important point, that a function at such is non-differentiable. Okay, a function is always non-differentiable at such ages. its way is clear. It's very simple. We can understand by that graph by any example. Like if we are going through this example of differentiable function, for example, this is a function in which if you are going to know slope of this point, this will be determined. This can be determined, or here you can determine as well. But if a function is, for example, like this, now at this point there is a sharp edge, right? So for this point it is not possible to calculate the slope, because this point, this is also a slope, this is also two tangents or two slopes. So at this edge you cannot determine, you cannot calculate slope. So this is the sharp edge, and here the function will be non-differentiable. Okay, so at all sharp edges any function will become non-differentiable. That's it. Okay, so now we want to discuss about two different approaches. One is mathematical approach, conceptual approach. Second one is graphical approach. So firstly we can cover that mathematical concept of both of firstly that continuity and here differentiability. Okay, so for continuity the condition is like that a function is continuous at x equal to a if value of function at a is equal to LHS and is equal to RH. If this is the case, the function will be continuous. Fx is continuous. If any one is not equal, that will become discontinuous. And of course, in the different cases, for example, all three are equal, it is continuous. If these two are not equal, these two are equal. If these two are equal, these two are not equal, that will be some types of continuity, discontinuity, like removable or non-removable, that we can discuss later on. But firstly we want to know about this concept, that if function, value of function is equal to left hand limit equal to right hand limit, the function will be continuous. Simple. Now let's talk about differentiability. Here the simple case is if f dash a is value of differentiated function is equal to left hand derivative is equal to right hand derivative, the function will be fx is differentiable. Okay, we will cover it by some questions. So these are the simplest cases of continuity and differentiability. Of course, when you are going through the graph point of view, I've already told you, if your marker or pen is lifted up while drawing the graph, that will be discontinuous function, and if it is not lifted up, it is continuous function. For differentiability, if there are sharp edges, so at that sharp edges the function will be non-differentiable, and if there is a smooth curve without sharp edges, that will be perfectly differentiable function. For example, we say let's take an example like fx equal to mod x, right? So mod x is a function which gives plus x and minus x. So its graph is when plus x, this is the line of plus x, and this is the line of minus x. So this is fx equal to mod x. Now it is clear that you can draw this graph without lifting your marker. So it is, yes, it is continuous function. This function is continuous function, but while drawing it, it's not smooth. There is a sharp edge at 0, right? This is x when x greater than 0, x less than 0. So this is a sharp edge at point 0. If there is any sharp edge at point 0, so this will be definitely non-differentiable function, right? So this is an example, and this is all concept about continuity, differentiability. This is the mathematical approach. Okay, so before solving some problems, I would like to focus on some important facts about continuity. So a discontinuous function will never be differentiable, but a non-differentiable function can be continuous. This is the first point, that a discontinuous function will never be differentiable, but a non-differentiable function can be continuous. What does it mean? You have already seen the example of modulus function, x equal to mod x, that was continuous but non-differentiable due to h. So this point, this line is already valid from that example. Now let's take this line. A discontinuous function will never be differentiable. How? For example, a function is breaking like this, so it will become discontinuous because this is the point of discontinuity. Now, is it possible to calculate slope at this point? No. there will be infinite number of slopes. So it is not possible to calculate slope over here, right? So the differentiability cannot be determined over here. So if a function is discontinuous, you will simply say, no need to check further, you will simply say a discontinuous function will be non-differentiable without solving the problem. Every constant, second point, every constant is a continuous. This is continuous. Okay. If any constant like y equal to 4, 3, something like that, that will be definitely continuous. All polynomial functions are continuous. Polynomial of any degree, either it is linear, quadratic, cubic, okay, quartic, quintic, anything, that will be continuous function. If f and g are continuous function at x equal to a, then f plus g, f minus g, fg, and f upon g will also be continuous at x equal to a. Definitely for f upon g, there will be condition that gx not equal to. Okay, this point will be for f upon g. And last one is an important theorem which is called boundedness theorem. And boundedness theorem says that if a function f(x) is continuous in a closed interval, so that will be bounded, fixed in that interval. It means if a function is only continuous in a given closed interval, so out of that interval we will not go for any point. Okay, reversing that, we can say for being a function continuous, there must be a closed interval, a fixed point. So these are some important facts. Please keep in mind. A discontinuous function will never be differentiable. It means calculate for continuity. If the function becomes discontinuous, simply say it is non-differentiable also. Okay, so we are ready to practice some questions. This is our first question. Let's see. Fx equal to 3x minus 2 when x is less than equal to 1, and fx equal to x plus 1 when x is greater than 1. So for given function, which statement is correct? Fx is continuous and differentiable at x equal to 1, continuous but non-equal. So these are 4 options. How will solve it? So I'm just giving you the short point how to solve it. X minus 2 and x plus 2. So just x equal to 1, we are going to check at x equal to 1, and here we calculate left hand limit, right hand limit, and f1. Okay, f1 because x equal to 1. So how will you calculate? Left hand limit means less than 1, so this is less than 1 point. When x is less than 1, so left hand limit will come from here. 3 into x is 1 minus 2. 3 minus 2 means, so left hand limit is 1. Now go to the right hand limit. Right hand limit means more value, more than n, 1. So x is more than 1 in this case. So here it is x plus 1, right? So x plus 1 means 1 plus 1, so it gives 2, and f1 means when x is equal to 1, here x is equal, again you will take 3 into 1 minus 2, so it will come. So from this, it is very clear that left hand limit is not equal to right hand limit. Okay, of course left hand limit is equal to f1 but not equal to right hand limit. So from here, if left hand limit and right hand limit are not equal, you will simply say, okay, this is discontinuous. Okay, so if it is discontinuous, the first point of important fact will come in picture, and it will be non-differentiable also. No need to calculate for that. So the function will become discontinuous and non-differentiable at x equal to 1. This will be the correct answer. Okay, so this is our second question. For y equal to x square when x is less than equal to 0, 1 when x is greater than 0 but less than equal to 1, 1 upon x for x greater than 1. Here more than one option can also be chosen. The function is, these are 4 options. Now firstly, see it that here are 2 points, x equal to 1 and x equal to 0. Means this function need to be checked on 2 points. From here also you can see that here is 0 and 1. So you will go one by one. We will solve. Firstly, at is value of x, there are 2 points of x, 0 and 1. Simply we will do the same question, and then left hand limit, right. Okay, and I already told you no need for to go for function. It is clear from left and right hand limit. So for 0, left hand limit means less than 0. So less than 0 means x square. So it means 0 square, it will become 0. Right? Right hand limit means greater than 0. So it is 1. So clearly left hand limit is 0, right hand limit is 1, because left hand limit is not equal to right hand limit. So at x equal to 0, function becomes discontinuous. This is the fastest method of solving the problems. Okay. Now let's go for next one, that is 1. So left hand limit less than 1, it's 1. Okay. For right hand limit means when it is greater than 1. So 1 upon x. So 1 upon x means 1 upon 1. So it will come. Now left hand limit is 1 and right hand limit is also 1. So yes, at x equal to 1, this is continuous. Okay. Now it is also talking about that x equal to 1, it is continuous, but we have to check for differentiability also. Okay. So for differentiability, we will solve it further. Simply just like this, we are calculating left hand and right hand limit. Just calculate x left hand derivative and right hand derivative. How will you calculate? I am just telling you. Okay. No need to do anything. Simply x square, this is function's first point, differentiate it to 1 here, and after differentiation it gives 2x. Watch it please, very carefully. X square becomes 2x. When differentiation of 1 will be, it gives 0, and you know differentiation of 1 upon x. Okay, it will give minus 1 upon x square. Okay, minus 1 upon x square. You know it. Okay, differentiation, I think that will be some other topic. If not, x square 2x, 1 to differentiation will be 0, and 1 upon x, differentiation of this will be minus 1 upon x. Okay, so now these are functions. For differentiation, for this condition, taking differentiability, these will become functions. So you need to check it at 0 and 1. Now I am telling you simply, that's why I have given that some important facts like that because at 0 this function is discontinuous, so no need to check at 0 because it already becomes, if it is discontinuous at 0, it will be non-differentiable from first point. It is discontinuous, so from discontinuity it will be also no need to check for it, but we will check for 1 because it is continuous. So being continuous at 1, it may be differentiable or non-differentiable, both are possible. Now let's check. So for less than 1, it is 0, so left hand derivative is 0. Now what about right hand derivative? Then x is equal to greater than 1, minus 1 upon x square. Okay, so minus 1 upon x square, put this 1, so minus 1 upon 1 square, it will be minus 1. Now that's interesting. Left hand derivative is 0, right hand derivative is minus 1. So it's clear that left hand derivative is not equal to right hand derivative, so it is non-differentiable at x equal to. Okay, so now check the conditions. It is saying continuous at x equal to 1 and differentiable at x equal to 1. No, because at x equal to 1 it is continuous but not differentiable. Continuous but non-differentiable at x equal to 1. Yes, this is the correct one because at x equal to 1 it is continuous and non-differentiable. Discontinuous but differentiable, this already eliminated. I have told you many times. Now fourth example, discontinuous and non-differentiable at x equal to 0. Yeah, at x equal to 0, this function is discontinuous as well as non-differentiable. So here two options are correct. So in graphical method, the benefit is that you need not to differentiate it and do all that stuff. You just draw the graph for this. When x is less than 0, it is x square. So this graph will be like that. X square is the parabolic graph, but it only comes for x less than 0 or equal to 0, so it will place over here. When it is 0, then 1. Okay. And then after. So between 0 to 1, it is 1. Okay, between 0 to 1, where 0 is excluded, it is 1 over here. So there will be a hollow circle. After this, there will be a line up to 1. And after 1, x greater than 1, it is 1 upon x. So 1 upon x, you know that graph is for 1 upon x and 1 upon x. Okay, so this is 1 and this point is 0. Okay, so now this is the graph for given function. You can answer all this question by this. So at x equal to 0 is this point and x equal to 1 is this point. You can see that x equal to 1, this function starts from here, but from here to here you have to lift the marker. Means at 0 it becomes discontinuous. It is discontinuous. Discontinuous was non-differentiable at x equal to 0, again this option. And at x equal to 1, this function is continuous. Because there is no need to lift. After this, you are drawing it smoothly without lifting the marker. But not smoothly, but without lifting the marker. And here at 1 there is a sharp edge. Sharp edge means here it becomes non-differentiable. Right? So at 0, it is discontinuous and non-differentiable. At 1, it is continuous but non. So these are again B and B options. So you can solve it also by this graph or graphical method. Question number 3. If fx equal to x plus 1, when x is less than equal to 1, 3 minus ax square when x is greater than 1 is continuous at x equal to 1. It is said that it is continuous at x equal to 1. Then the value of a is, there are 4 options. Okay, we will apply the same concept that at x equal to 1, we need to calculate left hand limit, right hand limit, and because it is said, this question is a basic tip that in this question it is already told that the function is continuous. Okay, so you will definitely do that left hand limit will equal to the right hand limit. Now calculate left hand limit for less than 1, so x plus 1. Function will be x plus 1. When you will put x equal to 1 here, 1 plus 1, so it will become 2, right? It will become. Now when you calculate right hand limit, it is 3 minus ax square, so 3 minus a into at x 1 square, so 3 minus, this is right hand limit, because left hand limit is equal to right hand limit, so 3 minus a is equal to 2, so 3 equal to 2 plus a, or 3 minus 2 equal to a, so a will be 1, option number. Okay, so this is the next question. If fx is root 1 plus px minus root 1 minus px upon x, if minus 1 greater than equal to x less than 0, and 2x plus 1 upon x minus 2, if 0 is less than or equal to x is less than 1, and this function is continuous at x equal to 0, then value of p is 1, 1 by 2, minus 1 by 2, or 3 by 2. Okay, so let's solve it. Same method will be applicable, like we will see at x equal to 0, because this is given that function is continuous at x equal to 0. So at x equal to 0, we will calculate left hand limit that will be equal to right hand limit, right? So at left hand limit at x equal to 0, right, left hand limit will be equal to right. So let's write it. Left hand limit means x equal to 0, so less than 0, this case, yeah, root 1 plus px minus root 1 minus px upon x, right? Now if you put 0 over here and here, it will become 1 minus 1 upon 0. When 0 comes in denominator, the function becomes, undefined. So it is not possible to put x equal to 0 here. This is basic, and it should be clear that you cannot put x equal to 0 directly over here, because the x is in the denominator. So you have to do rationalization in this question. This is the basic difference in previous and this question, that you have to rationalize this. So let's do it. Root 1 plus px minus root 1 minus px, right, into root 1 plus px, this minus will become plus, and root 1 minus px, and divided by x into same root 1 plus px plus root 1 minus. This is a minus b, a plus b, so it will become like a square minus b square, means squares will be eliminated, so 1 plus px minus 1 minus px upon x into root 1 plus px minus root 1 minus, right? So I'm writing over here, right hand limit will be calculated that side. So now 1 plus px minus 1 plus px divided by x into root 1 plus px minus root 1 minus px. Here 1 will be cancelled, px will become 2px upon x, and root 1 plus px minus root 1 minus px at x and x will be cancelled. And now you can put x equal to 0 in this value, so this will be 2p. When you will put 0 over here, this will become 0, this will become 0, so this will be under root 1 plus under root 1, this will 1 plus 1 means 2, so 2p upon 2, so it will be p. Okay, so left hand limit is coming p. Now just go for right hand limit. Now we will calculate right hand limit, and right hand limit means when more than 0, greater than 0, so this case 2x plus 1 upon x minus 2, and here you can directly put x equal to 0. So put 2 into 0 plus 1 upon 0 minus 2, so this will be 1 upon minus 2, yeah, means 1 upon 2. You know that left hand limit will be equal to right hand limit, means p will be minus 1 by 2, so p is equal to minus 1 by 2, that will be option number C. Okay, so this is the next question. Which statement is true about fx equal to mod x minus 1 plus mod of x minus 2? Okay, mod x minus 1 plus x minus. Okay, so here we can see that there are 2 points, 1 and 2. X is equal to 1 and 2. Okay, so the cases will be, you can see that we will solve for 1 and 2. So fx will become at 3 point when x is less than or equal to 1, right? Second, when x is between 1 and 2, and when x is greater than 2. Very important, just focus on it. Okay, so in first case, when x is less than 1, here it is less than 1, here it is also less than 1. So less than 1, it means it comes negative, and it also comes negative, so both will be negative. So here it will be minus x minus 1 and minus x minus 2. Okay, and it will become minus x, so minus 2x and minus plus 2. So this will be function for this case. Okay, I'm giving some space. Now second case, when x is greater than 1 but less than 2. Greater than 1 means this will be positive, but less than 2, so it will be negative. Positive and negative, it will be positive x minus 1, this will become negative x minus 2. Okay, so x will be cancelled, and minus 1 plus 2, so it will give 1, right? And third case, when x is greater than equal to 2, both will be of course positive, because greater than 2 means this is positive, this also positive. So x minus 1 plus x minus 2, this will be 2x minus 2. Now this question has become like fx equal to minus 2x plus 3, 1 and 2x minus 3 with different conditions, these conditions, right? So now you can solve it by either by any method, either graphical method or the conceptual method. So let's do it. We want to check the graph. We will draw it. Minus 2x plus 3, 2x plus minus 3 and 1. So that graph will be, if this is 1, this is 2, this will be minus 2x plus 3 line, this will be 2x minus 3 line, and that height will be 1. So this is at 1 and this is at 2. You can clearly see that at 1 and 2 there are two sharp edges. So at sharp edges it is not differentiable. So you can say that at both points, means at x equal to 1 and x equal to 2, at both points it is non-differentiable. So option number 4 is right option. You can solve it by other method also. Okay, this is the first one. I am explaining the second one also. Okay, by another method, that is conceptual method, not by graphical. So for that, we are going to calculate about differentiability. So we will calculate at x equal to 1 and 2 about left hand derivative and right hand derivative, right? So in differentiability, these will not act as function, but their differentiation, their derivatives will act as a function. So the derivative for this will be minus 2, right? Minus 2 into 1 plus 0, so minus 2. This 1 and this 2. So at x equal to 1, less than 1, left hand derivative means x less than 1. This will be the value of left hand derivative, and greater than 1, this will be the value of right hand derivative. Okay, so left hand derivative definitely not equal to right hand derivative. So here it will be non-differentiable at x equal to 1. Then at x equal to 2, left hand derivative means when x is less than 2, the left hand derivative is 0, and when x is greater than 2, the value is 2. Again 0 is not equal to 2, so at that point also it is non-differentiable. These two are the simplest cases of solving this. So it is non-differentiable neither at x equal to 1 nor at x equal to 2. Okay.